Okay, so the last topic is going to be recursion, and this is going to be one of the more challenging topics in the course, just because it's a lot to sort of get your head around this sort of idea of a function calling itself, which is what recursion is. Um, but you'll see that in a few minutes. But what I'm saying is that if you do need any help, I'm here for you via email or Zoom. And if you don't want to reach out to me, then reach out to your TA or to students on the discussion boards. So there are all these sort of resources for you if you have any trouble with this. Which, if you do, that's very normal because this is a tough topic. But let's get into it. Recursion is where a function calls itself. Okay, and it needs two things. We need a base case and a recursive step. Well, to sort of explain this, I'll do an example. So let's write a function called factorial of n, and it's a recursive function. Okay, well, factorial of 5, for example, is 5 times 4 times 3 times 2 times 1. I think that's 120. So that's what the factorial is. That's just the math of it. But how do we write a function, a recursive function, for this? So let's define our function. Factorial of n. Okay, and since it's recursive, we need a base case and a recursive step. So the base case is if n is 1, return 1. So if we call factorial of 1, if you look to the math, the factorial of 1 is 1. So that's what we're going to return. But in the other case, if n is not 1, then we want to return n times n minus 1. But how do we, or times the factorial of n minus 1. And why does this work? Well, what's 5 factorial? Well, it's equal to 5 times 4 factorial, which is equal to 5 times 4 times 3 factorial, and so on. And when if you do it on paper, you'll see that works. But that's the trick that we're using. We're saying, let's say we do 5 factorial. Okay, let's print factorial 5. Okay, so let's go into the function. N is not 1, so we go to the else. We do 5 times factorial of 4. Well, now let's go into our function for 4. 4 is not 1, so we go into the else. We do 4 times factorial of 3. Okay, factorial of 3. What's factorial of 3? We go into our factorial function. 3 isn't 1, so we go to the else. We return 3 times factorial of 3 minus 1 is 2. What's factorial of 2? We go into the function. 2 is not 1, so we go to the else, and we return 2 times factorial of 2 minus 1. So 2 times factorial of 1. What's factorial of 1? Well, if 1 is 1, so we return 1. Factorial of 1 will give us a 1. So what we're printing is really 5 times 4 times 3 times 2 times 1, which will be 120. And that's how we're handling the recursion, and that's how we're getting our output. Okay, so the base case here is this, and this is our recursive step. This is what we call our recursive step. So let's get into merge sort, which uses this idea of recursion in order to sort a list. Okay, Before we get into it though, just want to note that there are, for any given problem, say sorting a list or searching a list or some other thing, flying a drone, just note that there are many different algorithms that we can use to solve a problem, and one isn't necessarily better for all cases. You know, they're individual and they depend on sort of what you're sorting, what you're starting with your list. So let's get into merge sort. There are two parts to merge sort. One is actually merging, the merge operation, and one is the algorithm itself. Okay, now this graph, this drawing right here, is not the prettiest thing, but I like how it's numbering all the steps in the recursion, so we can sort of keep track of what's going on. So first, maybe we'll talk about merge, what merge is actually doing, and let's just use one of the examples to see how merge will work. And the merge step, well, the way this is basically going to work is it's going to split the list basically in half until we have a bunch of lists with one element. Okay, so it'll split this list into two parts. It'll then split each of these into two parts, and each of these will be split into two parts. And notice, well, this one doesn't need to be split. But we end up with a bunch of lists all with one element. So from here, this is where we do the merging. So we'll merge these two, and when we merge, we order them. So the 27 goes before the 38. And maybe a better example would be merging these two to this. We order the 3 first and the 27. So let's see how we would actually do a merge on these two. Okay, so we have 27 and 38, and we also have 3 and 43. Okay, so let's try to merge those lists and see that we're getting them in the right order through our merge operation. So let's look through this. Merge takes two lists, left and right. Okay. So left in this case is the 2738, right is the 343. We write a list. It's called merged. This will have all of our values in order at the end, but for now it's empty. L equals 0, R equals 0. These are sort of indexes to count where we are in these lists. So we're at 0, which means we're at the 0th element of both lists to start. What's the length? What are the lengths of these lists? Length of left is 2. Length of right is also 2. Right, there are 2 elements in each of these, so their lengths are both 2. So let's go into our while loop and see how we're going to merge these things. So is 0 less than 2 and 0 less than 2? Yes. So we go into the if loop. Basically what we're saying is at index 0 and index 0, because those are L and R, is this 27 less than 3? No, so we go to the else, which is the other case. That means 3 is less than 27. So we add this 3 to our list, which is called merged. So merged, we add the value 3. Merge.append. What is right R? Well, R was 0. Right at index 0 was 3. So we added the 3 to our list. Then we make R go up by 1. Why are we doing that? Because now we've dealt with this 3, so we want to focus on the 43 from this list. And we haven't yet merged this into our big list or into our merged list, so we keep the left index at 0. And we're still in the while loop, so 0 is less than 2 and 1 is less than 2, so we go in the while loop again. Is left 0 less than right 1? Because r is now 1. So is this less than this? Yes. 27 is less than 43, so we add it to our list and we increment L by 1. So we add the 27 and we increment L by 1. So we don't go to the else, we now go through the while loop again. 1 is less than 2 and 1 is also less than 2, right? So we go into our while loop, and now we're at index 1 for both of these. Is 38 less than 43? Yes, so we add it to our merged list. And we increment L by 1. We go back to the while loop, and we notice that 2 is not less than 2 strictly, so we are done with the while loop. We then have to add the remaining values, however many there are, and that's where we're using extend. So you've seen append before. What extend does, it adds the individual elements of a list instead of whatever you're appending. So to show you as an example, let's say A is 1, 2, 3, B is 4, 5, 6. If we said A dot append B, and we printed A, what do you think we would have? Let me comment this so that we can get something to run. What do you think this would do? This would take our whole list and it would add it to the end of A. So we get 1, 2, 3, and then B, which is the whole list. Right? But what if we don't actually want to add the whole list? What if we just want to add the elements themselves? Well, that's what extend will do. So if we say a.extend B, now we're actually just going to get the individual elements from the list. So that's what we're using here. And in this case, we're just adding this final value of 43 to our merged list. Because, so why are we doing that? So we have if L less than length of left. It's not. So we don't go into here. We go into the else. 2 is not less than the 2, right? So we go into the else, and we add from the right list, starting at index, basically to the right of index 1, so at index 1 and the rest of it, we add the 43. So we add the 43 to our merged list. And now we have all of these, we have both of these lists merged together and in order. And you can see how it would work for any of these smaller lists. But if you have any questions about any of this merging, then feel free to let me know by email or contact your TAs or post on the forums and stuff like that. So that's merge. Now to get into maybe the trickier part, which is the recursion, where it gets tough to trace it all, but we'll try our best. Let's go into merge sort. Okay. So we have our list, and our list has 1, 2, 3, 4, 5, 6, 7 elements. And the idea is the first thing we're going to do is split it. But the way we split it it might seem a little strange because we're using recursion here. So let's get into it. This is our base case, pretty much if we have a list of length 1, then we just return that list. But we will return it and it will be merged. These will all merge eventually. But this is our base case, and the recursive step is here when we call merge sort on a smaller list and merge sort on a smaller list. So recursive step meaning that we are calling the function within itself. So we call the merge sort function again. We do it 2 times for each call of merge sort. So there are a lot of merge sort calls that we're gonna go through. Let's start with the full list. Okay, the length of the list. Let's just see. So length list. We'll start with this, and we'll see how far we can get. So the full list is 7 elements. Okay. So we don't go into here. We don't return list. We go into the else. Midpoint equals basically the length of the list divided by 2. We'll round up in this case. So midpoint is 4. And we're going to split left and right. So midpoint is 4. Left is merge sort on the left list. Right is going to be merge sort on the right list. But we first have to do merge sort on the left list. So let's call merge sort on this list. Okay? So the length of this list is 4. Right? So we're here now. We're at this step where we're at the left list and we're calling merge sort on this list now. So when we call merge sort, we have to go into this function again. Okay? Length of this list is 4. Is the length less than or equal to 1? No, so we go into the else. Okay, the midpoint is 4 over 2. Midpoint equals 2. And basically all this is saying is we're splitting it in half. So we split this list into 2 parts. And now we say left equals merge sort on the left list. So we're now going into the left list here and calling merge sort on this. When we call merge sort on this list, the length of this list is 2. Right? So the length of this list is 2. The length is not less than or equal to 1. So we go to the else and we calculate the midpoint, which is 2 divided by 2, which is 1. Okay, midpoint is 1. Okay, and we're splitting the list into 2 parts and calling merge sort on this left one first. Notice we still haven't called merge sort on any of the right lists yet, because we've just sort of gone further and further recursively until we get to here. Notice when we're at the 38, when we call merge sort on this list, the length of the list is 1, so we return it. So we return this number back to here. Okay, so now the left equals merge sort. This is done for this list. So we called merge sort on the left part. Now we can go to the right. The right equals merge sort on merge sort of this list. Right? So merge sort on the right side of the list, which is the 27. Calling merge sort on the 27, we'll return 27. So 27 will go back to here, right? 27 will give us we'll return 27. So we now for this particular list, we have left, right? So left equals 38. We have right, so right is 27. And we're going to return left and right merged. So we return 27 and 38. So this one is done. So this one is done. But it's going to start to get tricky because now we're going back to here. Okay, and we go back to here because when we called left equals merge sort and right equals merge sort, we only dealt with the left. So the left was basically giving us this result. So it merged. We did all the calls that we went through, and then we returned this merge left right, which gave us this. So we dealt with this left side. We're now going to deal with this right side. We will get a bunch of stuff from this, and then we'll go back up to here and go to the right side again. But we're right here now. Okay, so we've dealt with this side. We're now going to say right equals merge sort on this list. Okay, so when we're in this list, we go to the left and to the right. Right, so we have the 43, for example. Let's say we have this list, 43 and 3. Merge sort on this list. The length is not less than or equal to 1, so we go into the else. The midpoint is 2 divided by 1, which is 1. We go to the left. Since it's one element, we'll return it. Coming back up here, we go right. Since it's one element, we return it. And then we merge these two together. So that's going to be step 10. And the result of this call, so notice how we did left, and then we did right. Now for this, right here, we're going to call merge. Okay, so we're calling merge left, right on this, which will give us this merged list, which is a sorted list. Now we go back up to this top step. We've dealt with the left side. We're going to now deal with the right side. So we said left equals merge sort. We did that. Now we're going to do merge sort on the right list. 982.10. So to do merge sort on this list, we go into merge sort, we create a left and a right, so left, right, and we call merge sort on each of them. Calling merge sort on this, calling merge sort on 982, we go into our function, it's bigger than 1, so we go into the else, we have a left and a right. The left equals we're calling merge sort again. So we call merge sort on the left part, which is the 9. This will be returned because the length is 1, right? So length is 1, so when we go into merge sort, for the 9, the length is 1, so we return it. Okay, so we return it back to here. We then go, for this list, we go to the right side. And every time, for each of these steps, so for this 9 and the 82, we're doing merge sort on the left. Notice how it came back. Then we do merge sort on the right, which is the 82. So merge sort on the 82 will return 82 because it's one value. Then we come back here and we return the merge of the left and the right side, which gives us 9 and 82. So that's dealt with this. Then we go back up here. We've dealt with the left side of this. We need to deal with now the right side. So right equals merge sort. So we call merge sort on this. Since it's the length is 1, we return it, and we call merge on ultimately this and this, which will give us the 9, the 10, and the 82. And then going all the way back up to here, we then merge. So we've done, for this big list here, we've done left, we've done right. Okay, so now we're going to do the merge step. Okay, so we are going to merge this and this, which will give us the overall sorted list. Now that's a lot, and that was a lot of talking from me, but if you're sort of getting any intuition for what this is doing from the explanation, then that's good. And if I do want to test you on this, I'll definitely put something out there in the exam review. But for now, just if you can sort of get a basic feel for what's going on and for recursion, then that's definitely good enough. I'm not expecting you to understand this. That's not really realistic at this point. You're going to need to go over it at least a good number of times in order to get a grasp for it. So don't worry if you don't at first get this. You will see recursion definitely in the exam review if I'm choosing to test you on it. But that'll be more clear. I'll make that more clear in the coming weeks as I'm writing the exam and preparing the review. So for now, if you can get a feel for this, that's great. If not, don't worry too much. But that's going to be it for merge sort. And if you've made it to this point, good job, because this has been a very heavy module. But if you have made it this far, congratulations. Good job. You should check out this page, and it sort of summarizes some of the different sorting algorithms that you can use, and we've only really looked at bubble sort and merge sort, but at least you can maybe get an idea for the different types of sorts. You don't have to know anything about this. It's just more for fun. And for next week, just take the time to finish up assignment 3 and maybe take a look at assignment 4. And if you need any help with those, feel free to reach me again by email, or we can do a Zoom call. So that's it. I hope you all have a great week.